The first topic of chapter 2 is factors and multiples divisibility rules. Divisibility rules are a very important topic in while solving an Olympiad because it can get you if the divisor will have a remainder or not. So it's very a fast trick and very easy for you to do. I've got 7 tricks for you that will make your life very easy when solving Olympiads. First one is to check if a number is divisible by 2. Let's take an example of 24. How do we know if it's divisible by 2? Just look at the last digit. If the last digit is even, which means 0, 2, 4, 6 or 8, that means that it is divisible. If it's not, for example 35, then it is not divisible. No matter how big the number is, all you have to do is look at the last digit. Let me take an example of a really big number. Okay, doesn't matter what all of these digits are, just look at this digit, and if it's even, tick, that's divisible. That is how simple its rule is. Okay, next we'll move on to the divisibility rule of 3. The divisibility rule of 3 states sum of the number's digits should be divisible by 3. What do I mean by that? Let's take an example of 27. 27. When we add up 2 and 7, we get 9, and 9 we know that is divisible by 3. That's as simple as it is. Let's take another example, a 4-digit number. 3, 4, 7, 8. Okay. And here it will be, we'll add all these up, which means 7, 14 and 22. Okay, so now that 22 comes, if you're not really sure if this is even divisible by 3, you can add these up as well and then just go 4. 4 you know is not divisible by 3, so you get your answer. That's how you do it, and that is the divisibility rule for 3. Next, if we move on to the divisibility rule of 4, it is that the last 2 digits should be divisible by 4. What do I mean by that? Let's take an example of 4840. Okay, these digits, they do not matter. We don't look at them. These last 2 digits are the ones that matter. They're the tens and the units digit. These are the ones that we look at and see if they're divisible by 4. 40 is obviously divisible by 4, so that means that this number is divisible. This is how you do the divisibility rule of 4. The divisibility rule of 5 is one of the easiest divisibility rules. It states that the last digit has to be either 5 or 0. You don't have to look at anything else, just if the last digit is 5 or 0. 4, 7, 6, 5, 9, 0. Doesn't matter how big this number is, this is 0, so it's divisible. That's how easy it is. Let's take an example where it's not divisible. 4, 8, 5, 9, 6, 7, 5, 0, 1. You see 1 5, 1 0 here, another 5 here. That doesn't matter. The last digit is 1. It's not divisible. Simple as that. So we can just next move on to the number 6. Number 6 is one of the more complicated ones. It states that if both 2 and 3 can divide the number, then 6 can also divide the number. Let's take an example of 432. We know that 2 can divide it because last digit is even, so 2 is ticked. And we know that 3 can divide it because 4 plus 3 plus 2 is 9, and 9 is divisible by 3, right? So that's as simple as it is. The main trick that I would use for this is, right now, make this arrangement that I made. Write 2, 3 and 6 and then test it, and once you get the hang of it, you'll be able to do this mentally. Okay, so if I'll take another example for this, 426 3. Okay, similar number, but this time it's 4 digits. Last digit not divisible by 2, but is it divisible by 3? 6, 12, 15. Yeah, it is divisible by 3. So now comes the question, is it divisible or not? It is not. If any of these numbers cannot divide it, it is not divisible by 6. As simple as that. Moving on to the next very important divisibility rule is 9. There are divisibility rules for 7, 8, 11, but those will not come in handy when you're in the second to fifth ratio. Okay. Next is sum of digits is divisible by 9. Okay. This is very similar to the 3 one, but in this case it's 9 rather than 3. We'll take 4, 2, 7, 8, 6, 9. Okay. This becomes 13, 21, 27, 36, right? 6, 13, 21, 27, and 36. And 36. So 36 is divisible by 9. So we know that 9 can divide this number. That's how easy it is. Doesn't matter how long the number is. If you get like a very long sum of the number, maybe like 432, you get as the sum. You can add these numbers as well, and then you can get 9, and that is also. So we're looking at the digital sum, and that should be 9 or divisible by 9. Finally, the divisibility rule of 0, very similar to 5, but in this case we exclude 5 as well. 4890 is divisible, but 4895 is not divisible because it doesn't end with 0. It has to end with 0 for 10. Those were the 7 divisibility rules that you will use in your Olympiad.